Okay, so today we're going to be talking about some mechanisms in chapter 20 and a small reaction wheel, basically. So, mechanisms and then reaction wheel. Alright, when we get there. So, first, we're going to be talking about the Bayer villager oxidation. So, this is when you have an RHOO compound and you react it with RCOOOH reactant, or we can also write it like an RCO3H, in which will give us this. So this is adding this OH group here as opposed to just the H. Okay, so let's do the mechanism. So we start with this, in which we have this to start with, and we're going to react it with the RC triple OH group. So we'll draw that like this. And this oxygen is going to attach to the carbon here, which will break this double bond. And it'll give us O negative here. This O is going to be positive because now it has 3 groups attached. And then this side of that product is going to remain the same. This oxygen is going to attach to this hydrogen, and then this bond is going to go back to the oxygen, giving us this is R prime. My bad. Don't forget to add your stuff so you don't get confused later on. And then because we added that hydrogen, we're going to have this OH here, but this oxygen is going to be positive because now it has 3 bonds attached to it. This bond is going to attach to this oxygen. This oxygen is going to go down. This oxygen is going to go over here, and then this double bond is going to go back there. And with all these arrows is going to give you 2 products. We're going to have this one with our R's groups and the product that we had before. So in the end, it's like kind of flipped. We have this equals this. And we also just look at another one. This one's using lithium aluminum H4. or La for short, so we're just gonna write La, lithium, aluminum, H4. So if we had this ring with a double bond and an H, react with the law with THF at a low temp, and react it with an H3O plus, we'd get the compound OHHH. This. So the mechanism for this one is going to be, you have this ring, right, what we started with. With the H is on the aluminum negative. We have this lithium over here. This oxygen, this hydrogen here is going to attach to the carbon here, so that double bonds break. And this is going to go back there. And this is just like 4 equivalents. This is 1 equivalence. Which would give us this, and then the oxygen is going to attack the aluminum with H3 to give us, and then we're just going to like redraw it for it to look better. And once again, we remember that I said it's 4 equivalents, so we'd get the aluminum here in the middle, and then we're going to have all these oxygens attached to it, the 4, remember, and then yeah, we'll stick with glue. All those rings are also still there, so you know. That, and then if we react it with some water, this bond here is going to attach to this hydrogen. Let me go redraw it real quick. And this bond is going to go back to that oxygen to give us the final product, this. And if you're wondering, is it the same thing? Yeah, because we don't always have to draw the hydrogens, the missing hydrogens with the carbons, as it's implied, CH2, H, and another H there. So in the end, we did get the exact same thing. And then finally, we're going to go on to the mini reaction wheel. And so I want to say this is for week 4, in case you wanted to know. So we had this. And we reacted it with Rainy Nichols reagent, which is this. Let's put that on the side. It's nickel, 2 hydrogens. We get the product. Of that. So as you can see, this one of these go there. This is gonna go back. This is gonna go down, and then the remaining of those that hydrogen, they're gonna go here to get rid of this double bond, and then the nickel is just gonna be free floating throughout. What did I? Oh, just deleted the double bond. And if we were to react it with 2 hydrogen with palladium, see? We get the ring again. But this time we got rid of the double bond there, and that's it. So the same thing with that. But if we were to use these reagents, sodium BH3, comma, methyl with an OH group, and water, we'd get the ring with the double bond is there, but instead of this double O bond, we're gonna get an OH group. Yep, so one of those hydrogens are gonna attach to here, and then this is gonna go down, and then the process is gonna keep going until in the end you get this product. And finally, the last one, more like a semicircle because we're missing the top half. Reaction wheel with lithium, aluminum, H4 or La, and water. We're going to get that. So the exact same thing. Once again, it's just 2 different reagents that'll give you the exact same product. And that is it. Thank you.